Hello everyone, hope you guys are doing well. Today I'm gonna solve one problem from British Math Olympiad. So before I start, please, if you have not joined to my channel, please subscribe to my channel down below here. And if you like, send this video to your friends. So because mathematics is not just for doing as a course, or it's more than that. It's something organize your mind and gives you better idea to solve your life problems. All right, so let's do this and solve this problem. This is pretty sweet problem. It's a functional equation, okay? So as I said, it's the problem from British Math Olympiad. I can write it down here. Whenever you see BMO, represent British Math Olympiad, and it's designed for high school students in 2009. Okay, so if you have watched my video, you notice that I bring several problems from the different countries that covers first level and second level of the Math Olympiad. However, some student told me that suggested me actually to solve some problem from the university entrance exam. So my next video after 2-3 days is gonna be university entrance exam problem. So please follow my channel. So I try to post more interesting problem every week. Okay, great. So let's jump to the problem first. First of all, the problem says find f of x if this relation is true relation. F of x times f of y is f of x plus y plus x times y, okay? X and y independent variable, of course. And note that whenever you see something like this means the domain R, okay, this is domain, this is range, okay? That means everything is defined in real numbers, right? Domain in real and range is real, okay? Or sometimes it's maybe mentioned in this form, R to R, same thing, okay? That means everything we are talking is in the real domain. Okay, so to solve this problem, whenever you see this type of formula, okay, try to put some basic numbers like 0, 1, -1, depends, okay, to get some idea what's going on. For example, best thing, let's put 0. For example, I'm gonna put y 0, okay? So if I put y 0 and then simplify, it's gonna be f of x times f of 0 is f of x plus 0 time plus x is x, y is 0, okay? For sure, this one is gonna be 0, this one is gonna be f of x, and this one is gonna be f of x times f of 0. Okay, great. And then you can bring this guy to the other side and take a factor of f of x. So f of x times f of 0 minus 1 will be 0. So whenever two terms are multiplication of them is 0, means one of them or maybe both of them gonna be 0. So either f of x is 0, okay, which means for every x is gonna be 0. So it's not a particular value, right? So is it possible? So we have to evaluate that. Or this guy is gonna be 0. f0 minus 1, 0 means f of 0 is 1. Okay? So let's, at least one of them should be true statement, right, to make this term 0. So first, I'm gonna keep this one and I'm gonna work on this one. Is it possible for whole term f of x is 0? Actually, no, it's not possible. Why? Because look at the original equation, f of x, f of y, f of x plus y plus x times y. If I put x, y, both of them equals 1, then what we have is, in the original equation, I mean here, so f of 1 times f of 1, or f of 1 squared, is f of 1 plus 1 plus 1 times 1 is 1. Okay? Then what I have is f of 1 squared is f of 2 plus 1. Okay? If this statement is true, means for all x, f of x is 0, means this one must be 0, this one must be 0, and then we have 0 is equal to 0 plus 1, or 0 is equal to 1. Is it possible? Of course not. Okay, so that means this guy is not possible or impossible. This statement is not true. Okay, so that means the only thing is f of 0 is 1. Great, so we got good thing here. So the other one, I'm gonna put x is 1, okay, and y is minus 1. Okay, see what we get here. So if you put in the original equation, f of x is going to be f of 1 times f of y is f of minus 1, is f of 1 minus 1. You get the idea. So that generates f of 0, that we have the value minus 1, right? X times y is minus 1 times 1 is minus 1. So this one is f of 0 minus 1, and f of 0, we got it here, is equal to 1. Okay, so 1 minus 1 is 0. Okay, that means f of 1 times f of minus 1 is 0. Okay, same scenario, either one of them is gonna be 0. Okay, so now I'm gonna keep this relation and I'm gonna work on this here. So suppose that, let me say, suppose f of 1 is 0. Okay, then I'm gonna say, instead of x, if I put another variable like k minus 1, okay, there's a motivation behind this changing the variables, and y is gonna be 1. Okay, now let's take a look at, if we put x is equal to k minus 1 and y is 1 in the original equation, what do we get? So we get f of k minus 1 times f of 1 is f of k, right? X plus y is k minus 1 plus 1 is f of k, plus k minus 1, which is k minus 1 times 1 is k minus 1. Okay, so if f of 1 is 0, then this guy is going to be 0, and the whole term here is going to be 0. Okay, and then what we get? We get f of k is, if you bring this guy to the other side, is going to be f of k is 1 minus k. Or you can put, instead of k, x, doesn't matter. So f of x is 1 minus x. So this is one solution, okay, if f of 1 is 0. Okay, this is one possible solution. So later on, we have to put this one in the original equation here, and then see, is it, or verify this solution, right? So this is a potential solution. The other one is, if f of minus 1 equals to 0 from this equation. Okay, so suppose f of minus 1 is 0. What happens here? Same scenario, instead of x, I'm gonna put here, for example, t plus 1, and y is minus 1. Okay, and then I'm gonna put in the equation, in the original equation. So I have f of t plus 1 times f of minus 1 is f of t plus 1 minus 1 is f of t. This is from the original equation. Minus t minus 1. Okay, so if f of minus 1 is suppose that it's 0, means this one is 0, the whole thing is going to be 0. Okay, then we have this guy equals to 0, or f of t is 1 plus t, or instead of t you can put x. Okay, without losing any generality we can put x. We have f of x is 1 plus x. Okay, great. So we got two solution. One is f of x is 1 minus x. The other one is f of x is 1 plus x. Which one is valid? So if you put in the original equation, which is f of x times f of y is f of x plus y plus x times y, you will see that both of them are gonna be the solution. Okay, for example, I'm gonna put one of them. Okay, the other one you can do it for yourself. For example, I put f of x is x plus 1 inside the original equation. Okay, what we have is f of let me instead of f of x I put x plus 1. Instead of y is going to be y plus 1, right? So just changing the variable. So instead of x plus 1, f of x plus 1 is going to be x plus y plus 1, right? So instead of f of x plus y, and plus we have x times y. If you simplify left hand side, we have xy plus 1 plus x plus y. Right hand side, x plus y plus 1 plus x plus y. Is it true statement? Yes. So that means this one is solution. And the other one is also, if you put it in the equation, it's going to be the other solution. Okay? Great. Wonderful. Thank you.